Okay, guys, this is the intro to chapter 16, 17 material. You're going to be doing series and parallel circuits over the next 2 weeks. And I wanted to just give you a little rah-rah pep talk, things to remember, things to think about. Number one, resistance is ohms. That is, resistors have ohms. Capacitance and inductance don't have ohms unless they're inserted into a circuit that has frequency. And you can see over here that the equation x sub c is 1 over 2 pi fc is how you convert a capacitor to ohms. The inductor needs to have a slightly different equation here. X sub L is equal to 2 pi FL. And that will also give you the inductance in ohms as well, given that you know the frequency. So, for you to do any kind of circuit analysis, you cannot be in Henrys and Farads. And these equations that you see on the screen here in red, and the equations below, they all work. Voltage divider, current divider, Ohm's law, Kirchhoff's voltage law, Kirchhoff's current law, they all work for you as long as you've converted your capacitors and inductors. Now, as you move through the book to later chapters, the book will already have converted the capacitors and inductors to ohms to save you the time. If you take a look at on the screen here in the blue, you'll see that even the impedances, impedance is the resistance of a circuit that has capacitors, inductors, and resistors. So if you'll have it, you have graduated to the big show now where we talk about all three, resistance, inductance, and capacitance, and we want them all to be in ohms, and we have these equations for series and for parallel in the green down at the bottom. You can see the equations for series circuit impedance. These will be your bread and butter equations. In particular, this equation here with the x through it, that equation works 100% of the time, every time, any parallel impedance circuit. And it looks like the equation of parallel resistors. And it really is, except that you can put any kind of ohms in for impedance as long as you know what the ohms are. So you will need these equations. I would warn you against trying to read too much into what the book is showing you in sections 1, 2, and 3, and try to go with these equations and solve 1, 2, and 3 equations very similar to the way that you learned series and parallel circuits in the 5th and 6th chapters. Now on this page, a refresher of sorts, to the left in black here is the series circuit, and you'll see that all the resistances, all the components have become Z. Z is the symbol of impedance. Z means I have a capacitor. Z means I might have a resistor, or I might have an inductor. It depends. It depends on what is in the circuit. So, I want you to also look at the parallel circuit. There are 3 resistors, Z1, Z2, and Z3, circled in green, and they have a frequency and a peak-to-peak voltage, just like the circuit above it in series, and that frequency needs to be known for you to convert capacitors and inductors to ohms. Once you are in ohms, everything works like chapter 5 and chapter 6. So, another point taken. Down here in the yellow, you can see that resistors from here moving forward in 16 and 17 All resistors, they receive a phase angle addition on the end. R at angle 0 degrees ohms. If you prefer to work in rectangular, you've got R plus J0. Whatever your resistor value is, the real part is R, and the imaginary part has a 0, which means it doesn't exist. So, capacitors, every capacitor that we will look at will always have a phase angle of minus 90 degrees tied to the ohms that you have converted. And if you want to use it in rectangular, the blue 0 minus jx sub c ohms works for you. You want my recommendation? Stick with the yellow circled values and use 0, 90, and minus 90 degrees for each of the three components, making sure to put brackets around your values, or you will end up with errors as you enter them into your calculator for polar and rectangular conversion. So, to summarize, be careful about using the Mickey Mouse formulas that are in your book in chapter 16 and 17, sections 1, 2, and 3, because they are special circuit equations which are complicated and difficult to remember. While using Ohm's law and voltage and current divider, you will become very, very well knowledgeable and start to remember your formulas so that you don't have to depend on those Mickey Mouse formulas. As we move into ELE 112, you will also be taught to stay away from those formulas as well. So let's get it going now, and let's kick off chapter 16 and 17 with a bang. Good luck and have fun.